Hello friends, how are you? Today we discuss the chemistry lecture series in which acid base is involved. Acids and bases and the salts. So what do you mean by the acids? Which compounds are acids and which compounds are having the bases, and what are the salts, and then salts hydrolysis. The salt hydrolysis produce the acids and bases. So today, one of the important concern, and that is the buffer. So buffers are used in various situations where the acidity or the alkalinity that must remain constant when any of a compound is added, any of the acids or bases are added, but that the pH value of that remain almost constant, and those compounds are called as the buffer. Acids buffer, alkaline buffer, the most one, that is um, the sodium acetate and acetic acid, that the salt of acetic acid with sodium hydroxide, and here that is of acidic buffer 4.7, and similarly here ammonia buffer, that is also of the with in that particular case ammonium chloride and ammonium hydroxide is there. So today we have, all of you have well known, one most important concern in our body is the blood. And when we are eating a number of chemicals related items, related foods, whatever those may be the acidic or those may be the alkaline. So whatever those we are using, certainly certain food are the acids also. For example, carbonated beverage where the carbon dioxide is present in pressurized carbon dioxide is there in carbonated beverage. So those are the soft drinks. So in that particular case, acidic is there. Similarly, so many things we are eating, and number of compounds we are eating, but the buffer of the pH value of blood remain constant. That is because of the buffering action. So buffering action itself is most important concern, and that particular buffering action in our blood, and definitely we are related with the life or whatever, and either so acids and bases. What are the acids? The simple way, the litmus paper. When we have to use the litmus paper, the acids converts litmus paper into the red color. So such compounds are called the acids. One of the definition of acid is that they are when they are used in certain metals, so metal can be treated for that particular because of the acids. The taste is also responsible, whatever that particular special taste is also connected with the acids. So now bases, what are the bases and alkalis? And one more thing is there, and all of you are well known about the periodic table. So in case of the periodic table, whatever the periodic table, alkali metals. So alkali metal compounds, whatever, if suppose sodium metal is there and sodium hydroxide is there. So sodium hydroxide, calcium hydroxide, NaOH, calcium, CaOH, whole of two. Periodic table, the group number one, alkali metal. Alkali metal, here the alkali metal, and that is the sodium, that is the potassium. So potassium hydroxide, sodium hydroxide. All of you have well known about the sodium hydroxide. This is the commonly the caustic soda. So caustic soda itself is sodium hydroxide. Then potassium hydroxide, KOH, potassium. So caustic soda and whatever the potassium hydroxide, caustic potash, caustic soda, both having the hydroxyl group. Sodium hydroxide, potassium hydroxide, and these we get from the group number 1 of the periodic table. Group number 1. Those are special alkali metals. Then next to the alkali metal, the group number 2 of periodic table, modern periodic table, I am mentioning, and group number 2, that is the second A group also, and another name is the alkaline earth metal. So earth itself is connected with the particular metals. Why? Calcium oxide, magnesium oxide, related with the earth metals, certain barium. So whatever this we can say, sodium hydroxide, potassium hydroxide, calcium hydroxide are the alkalis. Alkali word, whatever we have to see, alkali metal, alkalis. Alkali to word changes the alkali. Alkalis, alkaline. So alkalis are the bases. So those having the hydroxyl anion. Hydroxyl anion. So sodium hydroxide in water that can produce the sodium cation and hydroxyl anion. So those are the bases. Bases or whatever I have mentioned earlier. So systematically we can get from the periodic table who are the which are the bases and which are the acids. Now we come towards the different groups of the periodic table. We have to back to the then we follow what are the group 1, 2, 2, then last one, group number 18. But in the group number 18 and before that, that is the group number 17, that is the chlorine. So chlorine with hydrogen atom. So we can get that particular from, we can see the periodic table from this side. We have taken the sodium, then oxygen, and then hydrogen. And here from group number 17, group 17 itself is halides. That is the chlorine is taken, and chlorine with hydrogen, that become the hydrochloric acid. Hydrogen chloride, hydrochloric acid. So that gives a hydrogen cation. So this is the simple way how we can conclude that there are the specific space in the periodic table and specific space in periodic table, and as well as the electronic configuration of those elements which is responsible for that. So specific halides, hydrochloric acid. Specific sodium hydroxide, that is the alkali. Alkali, whatever, alkali metal, alkaline earth metal. That is also the name is also related with the alkalis, and those are the bases. So now we can say we have the discussed various aspects, and now we can say the buffers. So before going to the buffer, we have to know about the acid base concept. So what is the acid? However, we already discussed and already discussed the number of compounds: hydrochloric acid, the sodium hydroxide, then we have the potassium hydroxide, sodium hydroxide, then aluminum hydroxide that can be also taken, and then further hydrochloric acid, that is from the HCl. So HCl, hydrochloric acid, hydrogen chloride gas, hydrobromic acid, HBr, HI, hydroiodic acid. So is there any correlation in the periodic table? That is, the base thing is the electronic configuration of different elements, which provides us the whether such compounds are acidic and certain compounds are base. One more thing is there. So sulfuric acid we have to see the sulfur and oxygen and hydrogen. Hydrogen, sulfur, oxygen. That is the sulfuric acid, commonly called the Gandhaka Teja. So Gandhaka Teja itself is the H2SO4. So H2SO4 is also the example of the acid. So whatever the generally when the high sulfuric acid is there, so that can produce the hydrogen cation, and hydrochloric acid is there, so that can produce the hydrogen cation. And when caustic soda, sodium hydroxide is there, and in water, that gives the hydroxyl anion. So hydroxyl anions are produced from the alkalis, from the bases, and from acids the hydrogen cations are given in the particular, especially in the water, that is the aqueous solution. So here one more thing is there. If suppose we have the different acids, and for example citric acid, the tartric acid, so certain acids in the form of the solid. But what happens when those are in the water? So here the question is there, and that is the question: the dissociation of that particular acid. So strong and weak, that is related with the dissociation of the acids. So how we can explain that particular acid is strong and particular acid is weak? However, the dilution, the concentration is also relevant, that particular, if suppose concentrate sulfuric acid is there and dilute sulfuric acid there, so there will be the variation in the power, variation in the strength. Further, we have to know that uh, what is the meaning of the strong acid, what is the meaning of strong base, and all those can be correlated with the dissociation of that particular compound. So sulfuric acid, the strong acid, whereas we can compare the sulfuric acid, all of you are well known about the acetic acid. So concern of the acetic acid, acetum is there, and that is the, so what do we have? Vinegar. So vinegar itself, the present is the acetic acid, CH3COOH. Now, if suppose water is not there, and instead of water, other solvents are there, then the effect, the strength of that particular vary. If suppose nitric acid, all of you well known about the HNO3, nitric acid. So nitric acid when present in water and nitric acid present in the alcohol. Why alcohol? Because all of you are concerned about the drinking of alcohol. So if suppose something nitrates or whatever the role of the nitric acid, and definitely that will give us certain nitrates. So therefore, those are the, what are the chemical reactions of those acids with the alcohol? So definitely nitric acid when present HNO3 in water, one thing, the dissociation, and HNO3 in alcohol, another case, HNO3 in other organic solvent. So that is the effect of role of the solvent is also important concern regarding the relative strength of acids and bases. So which acid is stronger in particular solvent, which acid is weak in a particular solvent. So that is the relative strength of acids and bases are important. The ionization order I have discussed, law of mass action. This is also related with the dissociation of these. And further, we have the most relevant. Those are the ionic product of the water. This one is also connected with the ionization or whatever the ionic product of the salts. So salts are the hydrolysis of the salt, then different. So here we can get that that is the particular in case of the buffer solution. Those are the mixture of something, the salt and related acid or bases. Ammonium hydroxide and with ammonium chloride. So ammonium chloride is the salt and ammonium hydroxide is the weak base. So weak base and whatever the called ammonium chloride, and that become ammonia buffer. So buffering, so buffers are whatever the simple definition of buffers are typically consist of an acid base pair with the acid and base differing by the presence or absence of a proton that can be correlates with the conjugate acid and base pair. So, for instance, one of the buffer that maintain the pH of human blood involve the carbonic acid. That is that whatever that is related. So, what about the carbonic acid? So, in our cases, the buffer, the maintaining of pH of that is the combination of carbonic acid and salt, and so that is maintain the pH of our human blood. If that is not there, so certainly our blood may be acid. Whatever, if suppose acid is there in the food, then whole blood will be acid. And if alkali is there in the coming food, then certainly we are the alkaline. So this one acid base pair concept is there. So here the conjugation. Conjugation means the acid base and then further the acid base, whatever the reaction, and that is as per the Bronsted-Lowry concept of the acid and bases. So certainly there are the three theories are given, and then given on the time by time. Whatever we are discussing about the hydrogen cation, the hydroxyl anion, those are given by the Arrhenius. And later on, some problems appears that some solutions require, then Bronsted-Lowry concept was given. In that particular case, conjugation of acid and base occur. When acid reacts with base, then another equilibrium, another side, there will be the base of acid. So which acid then will that become the base. So this one is the conjugation acid base repair. Okay, so now we have to continue about the buffer, whatever this changes only here this one. So whatever buffers we have the another definition, and this definition buffer solution is a solution that changes pH only very slight when small amount of strong acid or strong base are added. So that's why. So the solution that we have the example of the blood. So blood having if strong acid or strong base is there added, then only very slight changes in the pH value. Otherwise, that remain the constant almost. So buffer contain a significant concentration of both. Here, whatever we can say, what are the buffers and the chemistry behind that, and that we can explain that which acid and base can form buffer solutions. Here, one of the uh, known acid buffer and alkaline buffer. So the most one we are using, and that one. However, there are the certain other buffering agents buffers are available, and which holds the pH nearby that ammonium chloride, ammonium hydroxide. So ammonium hydroxide. Before that, we have to come another one of the important concern, and that is the weak and strong bases. So weak acid and weak base. So what do you mean by the weak acid and weak base? Whatever I have discussed, which one will be the strong acid and which strong base? Already we have discussed earlier that the dissociation. So dissociation of if suppose that before that going to dissociation or the ionization, we have to come to the point, and that point itself is how much amount of percentage of how much amount of percentage of molecules are dissociated. Whether if suppose 100% dissociation is there, so therefore after 100% dissociation 100, then hydrogen cations are more, and that will be strong acid. If dissociation constant is very low in that particular case, So therefore, they relates with the dissociation constant. So dissociation, if we can say the strong acids. So strong acids dissociated more as compared with the weak acid. So weak, similar to that, that is also concern of the weak base and as well as the strong base. So let's we have to continue for that that various examples, various acids, various we have discussed various number of acids we already discussed sodium hydroxide, sodium carbonate, sodium bicarbonate. So what is the sodium carbonate? What do you mean by the sodium bicarbonate? Sodium sulfate. So sodium sulfate is the salt or the acid or the base. Sodium carbonate. Sodium carbonate, sodium hydroxide as well as the carbonic acid. So that will be H2CO3. So H2CO3 carbonic acid as well as the sodium. So sodium hydroxide reacts with the carbonic acid, that is the weak acid. So then sodium carbonate is formed. Here we are using one more thing is there, and here we are using suppose acid buffer. For that purpose of the acid buffer, for example, some 4.7 pH, we want to remain there. So there, weak acid and its conjugate base are used for that purpose. So acetic acid and conjugate base, there may be the whatever this there will be the sodium acetate. So sodium acetate, the conjugate base of acetic acid is the acetate. So acetate and sodium acetic acid both are there. So weak acid and its conjugate base are there. So acetic acid with the sodium acetate. So here the conjugate of acetic acid, conjugate base is the acetate. Acetic acid CH3COOH, and acetate part when we have to remove the hydrogen cation. However, this is the weak acid. Acetic acid is not a strong acid. So sulfuric acid is strong, hydrochloric acid is strong because of the condition, the dissociation of that particular compound. Hydrogen positive and we have the chlorine negative and the dissociation. In case of the acetic acid, this is the weak one. So weak acid, acetic acid and conjugate is the acetate. So acetate in the form of we are taking the sodium acetate. So sodium acetate itself is the salt. Salt of which one? Salt of acid and base. So acid is acetic acid and the base is the strong base, and strong base is the sodium hydroxide. So we have already discussed the alkali metals, sodium hydroxide. So sodium hydroxide combined with the acetic acid and formation of a salt, and that salt is of weak acid with the strong bases. So sodium acetate, that salt is taken because in that particular salt, if we have the sodium acetate, so acetate part is the conjugate base of the acetic acid, as per Bronsted-Lowell theory regarding the acid-base concept. So according to Bronsted-Lowell theory, that when we have the A acid and then base reacts, then certainly they will gives the respective base and respective acid. So that is the conjugation between the acid base. So here conjugation between the acetic acid and acetate. So acetic acid and acetate, there is a so weak acid. So this is the concept behind the buffer acid base. The sodium acetate buffer, this buffer relies on the dissociation reaction of acetic acid. So therefore this is the acetic acid, and whatever here also mentioning something. Now, those can also be correlated with the pH value. So, what is about the pH of the solution? And any all of you well known about that pH itself is one of the that particular pH value indicates for the solution, and solution whatever the aqueous solution we are using for the the pH itself is related with the how much particular solution is acid and how much particular solution is the is base. So that can also related with the hydrogen cation. Earlier, according to Arrhenius concept for the acid and base, and that Arrhenius concept was given, and when Arrhenius concept was given by the Arrhenius, and this states that acids gives hydrogen cation in the solution. That concept. So, if any of the solution we have, then hydrogen cation is given. So that is hydrogen cation is also called as the proton because the electron is not there. So only in nucleus proton is there. So proton is. So how we can say the how much amount of protons are present in a given solution. So that will be the correlates with the pH value. So pH is the whatever this is the one of the parameter to check that is whether the solution is the acidic, solution is the basic, and that have the very magic numbers are there, and that is the pH and buffer. The pH of a solution is the measure of the concentration of hydrogen ion in the solution. A solution with a high number of hydrogen ion is acidic and has a low pH value. So here the concept, whatever the concept itself is given the hydrogen ion concept. So hydrogen ion concept, and if hydrogen ions are more, then pH is negative. pH is whatever disproportionate. So if pH is 1, then definitely that particular solution will be strong acid. If pH is 4, so that will be the weak acid. So this reverse correlation between the pH and hydrogen ion concentration. So what about the pH value? So here a solution with a high number of hydrogen ion is the acidic and base has low pH value. So this is the concept. Whatever the with the help of the pH value, we can say that particular combination as the best buffer, and particular combination is not useful. So we have the something the most one, the acid and base. They are weak acid. They are the whatever the weak acid and the weak base. So we can identify that particular things with the help of the pH value, pH measurement, and pH measurement is very well known. With the help of the filter paper, we can check that particular filter paper whether the color changes. I think all of you know about the filter paper. So if color is changed from the filter paper color to the red, so those solution are the acidic in nature. So this can be measured, but how much the pH value is there, so that can be used by and with the help of the pH meter. So the pH measurement is one of the important concern. Suppose we have the creams, we have the saliva, we have the whatever those are the perspiration, anything we can measure the pH. For the blood, we can measure the urine, we can measure the pH value. So whether the urine is acidic or the alkaline. The blood is acidic or alkaline, this can be dealt with the help of the pH meter. So here a solution with a high number of hydroxide, and that again for the bases. So with a high number of hydroxide ion is the basic and has a high pH value. The same thing is there, but this is the POH. So negative hydrogen ion concentration is the pH. And what about the POH? That is the negative hydrogen and concentration. So in this particular case, solution with a high number of hydroxide is the basic and the high pH value. Their pH value is high. The pH scale range from the 0 to 14, and the pH value of 7 remain the neutral. Being here are the one of the example of the buffer action, how buffer can give the action towards the coming if we have the solution and coming addition of the different other acids or buffer acids or alkalis are added into that. So here one of the example, if suppose we have we can add hydrogen cation from the strong acid, so therefore this will remain as such. So this is the action provided if suppose hydroxyl ion from the strong base, but that remain as such, no changes in the solution. If no change in the pH value, and if suppose there happen, that will be very slight change, not a regular change, whatever that. If suppose 4.7 is there, so there may be the 4.7 to, so very small changes when a strong acid is added. So for example, if we are using the sodium acetate and acetic acid, that is the acid buffer. So in that particular acid buffer, if a strong acid is added in that particular solution, so definitely there will be no change in the pH. Similarly, the hydroxyl, so whatever the hydroxyl ion concentration, that is in the left side. So left side we have to see, that is the addition of strong alkali, but there is a little change or no changes in the pH value of the solution. So let this can be easily seen, and now we have to see that is also how the function of this, and you can see the easily the role of the buffer. So how the chemical reaction happens. So here addition of hydroxyl strong base is added. So what happened? Here acetic acid, and this is the acid buffer. So acid buffer is the mixture of weak acid with a salt of weak acid and strong base. So this is acetic acid. This is one of the weak acid because the dissociation acetic acid is very poor. So therefore acetic acid is example of the weak acid. Then the salt. The salt, for example, we have already discussed that acid and base combine with each other and they gives the salt. So here acetic acid and sodium acetate both are the mixture of and that particular mixture is uh, the called the buffer, and that is the acid buffer. So we can say their action, how they can action happen if we addition of the strong base. Strong base, what happen? That is the hydroxyl ion concentration. So strong base having the dissociation, more and more dissociation. So therefore, here when we can see the picture, whatever that hydrogen cation is there, and here the dissociation of acetic acid is very poor, so therefore this is weak acid. So when hydroxyl ion is added, so the hydrogen ion given up, given combined with the hydroxyl ion, and that safely gives the water. However, when we can add the acetic acid, so no, no. If we add the strong acid, for example, hydrochloric acid or sulfuric acid are added, so in that particular context, hydrogen cations which are uh, produced by the strong acid. So the role of strong acid to get the strongness, and however this particular hydrogen cation and the weak base of the concerned compound, that is of the acetic acid acetate ion, so though both combine with each other and definitely they gives us the acetic acid. So therefore, whatever then the role of the buffer, where the addition of strong acid and strong base, those can be nullified. So here next to that is the very significance of buffer. We have already discussed. Buffers are the solution that moderate pH changes, moderation of that particular solution when an acid or base is added to the buffer system. One more thing, buffers are the important in the biological system because of their additiveness ability to maintain constant pH condition. Constant pH conditions are only happen in the biological sense in our the life in the human structure. So there must be the buffering phenomena. Why buffering phenomena? Because the buffers maintain because of the buffering material, the pH of body remain the pH of body can be maintained. However, that can be also with the connected with the urine of a human being. So now there are some questions, some queries, and one first query is that further the training for the students we have given the different questions. Those are of the multiple choice questions or whatever the certain. So we want to give all of you to give the answer. Carbonic acid, one of the thing. So the carbonic acid and sodium bicarbonate. Anyone can give the chemical formula of carbonic acid and sodium bicarbonate. Both are present in blood as a buffer. So here the carbonic acid itself is what? Animal. And sodium carbonate is what in the present context or whatever the main, the common name of the sodium bicarbonate. Sodium bicarbonate, the carbonic acid. Carbonic acid, the weak acid. Okay. Sodium bicarbonate. So bicarbonate is from where? Anyone. So sodium itself, sodium is sodium hydroxide. Sodium hydroxide is alkali, and that is example of the strong base. And this when combined with H2CO3, carbonic acid, so what will be the product? Here, if one hydrogen cation is substituted, then HCO3 will be formed, and that is the sodium bicarbonate. Sodium carbonate is other thing, and here the concern of the sodium bicarbonate. What is the chemical formula of sodium bicarbonate? NaHCO3. Sodium bicarbonate itself is the so sodium bicarbonate, a combination of sodium bicarbonate with the carbonic acid. So, what is the meaning of the carbonic acid? What is the chemical formula of the carbonic acid? So, anyone can suggest the chemical formula of carbonic acid, and here the question is there the carbon dioxide combined with the water and then H2CO3. H2 CO2 plus H2. So that is the carbonic acid, and that is also all of you well known about the soft drinks where the carbonated the drinks or whatever the sodium here. So what will be the answer? Carbonic acid, H2CO3, 1 3, H2CO3, then sodium bicarbonate, and that is the NaHCO3. So if both are there in the blood, so buffering action will be there. So the answer itself is the whether that this statement is true or false. Anyone. So that is true. And explanation regarding this question, a solution that registers the changes in the pH value by addition of a small amount of acid, very small amount of acid or base is called a buffer solution. The buffer system present in the blood is the carbonic acid and sodium bicarbonate. So this one is the correct answer. The correct answer is the A1. Carbonic acid, H2CO3. Sodium bicarbonate, NaSCO3. So both are present and both become the buffer. So if suppose one of the that is not there, so definitely there will be. So there are some different disease are concerned, and disease for human beings are concerned, that the role of buffer itself is very important to maintain the life sustainability, and life sustainability itself is controlled by the buffer. Now we have the another question that will related with the dissociation. So which of the following equation used to calculate the pH value of buffer for an acidic buffer? Here the pH itself, the negative logarithm of hydrogen ion concentration. Then we have the K, pK, this one is the dissociation constant of acids. Then log of the salt and acids are there. So POH is equal to the second one, B part. B part, POH is equal to pK plus log of salt oblique acids. So what is the correct answer is the first one. pH is equal to pK. pK itself is the whatever that is can be related with the hydrogen ion concentration is the pH, and acid dissociation constant K is the pK. Then log and the salt upon the acid. So this one is a equation that is used to calculate the pH of a buffer solution for an acidic buffer. This is equal to pH is equal to pK plus log of salt upon acid. So here this equation is known as Henderson-Hasselbalch reaction, and this is used for making of the buffer solution. So this is Henderson's reaction and Henderson's equation that is important. Now the next questions, and buffer solution is destroyed. When are the buffer solutions are destroyed with the addition of a weak acid? One thing is there also. Any of the thing, whatever the material present in the earth, on the earth, so that may be decomposed, whatever the destruction. So if suppose human being, so human being itself, the death will be there after within the 100 years. So 100 years, this one is the destruction of human being. So after human being will be destructed because of the nature, because of the condition. So similarly, the buffer solution is destroyed when buffer solution is addition of a weak base, one thing, addition of strong base or the base, and addition of weak base, weak acid, and addition of a salt. So here addition of a weak base. So what about in case of the ammonium? In case of the sodium acetate and acetic acid. So which is the weak acid? That is the acetic acid. So addition of acetic acid definitely destroyed the buffer solution. If the addition of a strong acid or base changes the pH of a buffer by unit, the buffer solution is assumed to be destroyed, and that is the new pH is equal to pK plus minus 1. That means equal to 1 upon 10. So therefore, the relevant answer is addition of the weak base. Now another question here, buffer capacity, and that all of you are well known about the any of the parameter. Those parameters are responsible for the giving the capacity for the human being. So here we can say uh, that is the question is there. What is the buffer capacity of 3 moles are added in 5 liter of solution to changes the pH by 2 units? So here the answer is the D, 0.3 is the answer, and buffer capacity is defined as the number of moles of acid or base added to 1 liter of the solution to change the pH by the unit. Therefore, here buffer capacity will be 3 upon fifth divided by 2, and that is the answer is the 0.6 upon 2, and this is 0.3. So the correct answer itself is 0.3, and that is present in the. So here we can get the there is the another question, buffer capacity of the given by 2 units for a change in pH by unity, and what is the number of moles per acid are added 1 liter of the solution. The correct answer is 2. Here the explanation. Buffer capacity is denoted by star and number of moles of acid or base added to the 1 liter of the buffer by a change in pH value. So here we can say the changes in pH is given by 1 and the buffer capacity is given by 2. Therefore, by substituting, we get that 2 moles of acid or bases are added in 1 liter of the solution. So that is the thing regarding the buffer capacity. And now the next one, the pH of a substance is given by 3. And then what is the pOH value? Here the answer is the 11. So 11 plus 3, that is the 14. We know that the sum of the pH and pOH of any is the 14. If 3 are there, so definitely there will be the 11. So here the pH of a substance is given by 3 and then pH of a substance is equal to that is the answer is the 11. So thanks for everybody, and I hope that you have enjoyed this lecture, and this is one of the specific presentation by me because here we have to concern about the human body ourselves, where the buffer of carbonic acid and sodium bicarbonate that is useful. And I think all of you know about that sodium carbonate is which one? Anyone? The sodium carbonate having the common name. Sodium carbonate having the common name. But in our the blood, that is the carbonic acid and sodium, carbon, hydrogen carbonate. Sodium bicarbonate is there. So sodium bicarbonate is the combination of the strong base with the weak acid. So weak acid is the carbonic acid. So what is the sodium bicarbonate? Anyone? Sodium carbonate itself is the baking powder or baking soda. Which one? Baking powder. So baking powder, baking soda. Which one? So correct answer is the baking soda. Baking powder is the whatever the other different chemicals are added, and that can also the role of the buffer itself is very essential for ourselves and miracle in our life. So, can conclude here the buffers are very important to run our life because if a strong acid is inside us, we are taking, then there is no change because of the buffering action. Yeah, and then generally buffers are what are those buffers are the combination of weak acid or weak base and with their respective salt. So respective salt coming, and those are the respective salts are of the strong base and weak acid. So this is all about. Anyone have the query, then he or she can ask me the questions whatever they want, and all the best to all of you and having the patience with me and listening. So for that purpose, I am thankful to all. Okay, so all the best for all. So here the question. Anyone can ask me the question or the go to the uh, email and he or she can send me the ask me the question related with the email. And you can also come to on the Suresh Ganviar website and see our different programs. And that Suresh Ganviar University is one of the world level university. Okay, all the best.